Okay, so let's go ahead and move on now to discuss inductive arguments. And we're going to continue to evaluate them, right? That's what we're doing with deductive arguments. But the important thing to note here is that the terminology will shift, right? As you can see here from this slide, first of all, we're going to be asking whether or not inductive arguments are not valid or invalid. Those terms don't apply to inductive arguments, but rather strong or weak. Now, what you want to do is you want to ask this question first when evaluating inductive arguments. Do the premises, if accepted, if assumed, if you pretend that they are true, do they in fact make the conclusion likely to be true as the author suggests, right? So again, we can remember, as we learned in 1.3, what it is that makes something an inductive argument is that the author of that argument thinks that the conclusion is not guaranteed by the premises, but simply that they think the conclusion is likely, is probable, based on the premises. So, again, the question here is, let's assume that the premises are true. Is the conclusion then probable as the author suggests it is? If you answer this question with a yes, then you are saying it is a strong inductive argument. And if you answer the question with a no, then you would be saying it's a weak inductive argument. And so you might notice here there's an important distinction between strong and weak versus valid and invalid that we were talking about with regards to deductive arguments. Strong and weak are a matter of degree, right? So you can have a strong inductive argument, and you can have one that's even stronger. You can have a weak inductive argument, or you could have one that's even weaker. With validity, a deductive argument is valid or invalid. It's not almost valid. It's not partly valid. It's either all the way or not at all. So the analogy here that I like to make is that validity is more like a light switch that's either on or off, whereas strength and weakness here for inductive arguments is more like a dimmer switch, right? So it's brighter or it's dimmer, depending on how that knob is turned, if we're talking about a dimmer switch like that. All right. So now, to illustrate or to think about inductive arguments, we are going to have to, well, go to a casino, right? Of course, I'm not going to take the camera to a casino, and in fact, we'll do what we typically do in philosophy, and that is we'll just simply take a field trip of the mind here, right? We'll just simply go to a casino thinking about one. And so with that in mind, right, I will just share with you that I don't know a lot about casinos. I kind of have a longer commute, and I think I pass no fewer than 4 casinos on my way home, but I have yet to gamble in any of them. And that's not because I think that casinos are the devil or anything like that. It's just that I like money, so I like to hang on to it and don't let casinos have my money. So, having said that, I imagine, and so my knowledge here of casinos is fairly limited, but I pretend, I guess we could say, that there's some people who can't get enough action in a casino, and so in fact they are out in a parking lot throwing a die and making wagers on that. And so I'll just ask you to imagine what that might be like here. So here's an example of what I'm talking about. Let's say I told you I have a regular 6-sided die here. Therefore, when I throw it, it'll come up a number greater than 1. So that is an inductive argument, right? It's more specifically, it's a prediction. The conclusion is about what will happen in the future. What will happen in the future, I'm predicting, is that it'll come up a number greater than 1. I said, therefore, probably, right? So it's also an inductive argument for that reason. It says probably right there in the conclusion. So the question is it strong or weak? So what we will do is we'll assume that I am holding a regular 6-sided die, that the premise is true. And when I throw it then, is it in fact likely that it'll come up a number greater than 1? Yes, it is, right? I mean, there are 5 options there for it to land on. So that would be a strong inductive argument. On the other hand, I could say, oh, I have a regular 6-sided die. Therefore, when I throw it, it'll probably come up a 6. Well, apparently I've done my math wrong there, right? Because in fact, it won't probably come up a 6. Assuming this is just a regular 6-sided die, the odds are not in favor of that happening. And so that would be a weak inductive argument. Consider this. I have a regular 6-sided die. Therefore, when I throw it, it'll probably come up a number greater than 2. Well, if you think about the odds there, in fact, it is still likely that it will come up a number greater than 2. And so it is still a strong inductive argument, though we can note that it's not as strong as that first inductive argument. Here's another one. I have a regular six-sided die. Therefore, when I throw it, it'll probably come up a 5 or a 6. Well, the odds are not in my favor there, and so it would be weak. Not as weak as that second argument I offered, but it certainly is a weak inductive argument. Now, at this point, you might be wondering, well, what if the argument said, I have a regular six-sided die, therefore when I throw it, it'll probably come up a number greater than 3. Now, of course, the odds there are exactly 50-50, and so do we call that weak or strong? And in fact, we would really want to say neither. We'd want to just simply say, well, the odds are exactly 50-50 on that, and that's the most accurate way to kind of describe the nature of that inductive argument. Please rest assured that on the exam, when I'm asking you to determine strength and weakness for inductive arguments, I won't ever give you any that land right at 50% just to see what you would do. And also, I want to let you know that you won't need a calculator to do any particularly sophisticated odds calculations here. The likelihood of something happening will be fairly clear, I hope, from the premises. All right. So anyway, let's imagine in the parking lot where people are throwing the die and making wagers. It's starting to rain by now, no doubt. And so I'll imagine that I'm going in to play blackjack, right? 21, where I'm trying to get to 21 but not go over. And then the house, the casino, is attempting to do the same thing as well. And by the way, I noticed here that I have become quite blurry. I assure you that I'm not blurry in reality. And in fact, the camera will tend to refocus at some point. So hopefully that happens soon. Maybe if I move around a little bit, kind of gets its bearings. I don't know. We'll have to experiment a little bit. Okay. So blackjack, though, 21, right? Let's imagine this happens. I'm playing and I say, oh my goodness, I've got a pair of 10s. Therefore, I'll probably win if I take one more card. Okay? Now, if you know anything about blackjack, you would recognize that that is in fact unlikely, right? If I take one more card, unless it's an ace, I'm going to lose. So that is a weak inductive argument then, right? At the same time, do recognize that I could still win, right? I could be sort of this naive blackjack player, and I could take one more card. It could turn out to be an ace, and I could, in fact, win. Even if that happened, though, please recognize this argument would still be weak, right? What happens in the real world will not affect the strength or weakness of this inductive argument, and it is no doubt inductive and weak, and I would probably lose. But I would learn from that, right? Because I would say, I've got a pair of 10s, therefore I'll probably win if I just stay put. Now this, if you didn't know the odds, this is in fact strong. In fact, I think it's about 17. If you have cards totaling 17, you want to, the odds are about even at that point. Anything higher than 17 will be in your favor to just stay put. Don't take any more cards, right? You're learning a lot about gambling here today. You're welcome. So that's a strong inductive argument. Notice again, though, I could still lose, right? I could still lose. Given my luck, I probably would, honestly. Let's say I move on, because I get discouraged, right? And I move on to roulette. But I'm not just going to jump right in, right? Roulette is the wheel where you've got a ball that spins around, and on that wheel you've got almost half the slots red and almost half the slots black. And I say almost in both cases there because there are 2 green spots on the wheel for the ball to fall into. And I'm going to watch what happens in roulette before I place any bets. And you know what happens is that, in fact, I notice that black has come up the last 5 spins. So 5 spins in a row, that ball has landed in a black slot there. And so I think to myself, my goodness, right? The odds have definitely gone up for that ball to land in a red slot the next spin around, right? Well, in fact, this argument, and this is important, this argument is weak. Odds have not changed. In fact, on any given spin, assuming a fair table, the odds that the ball will land in either a black spot or a red spot are always the same, and they're always slightly less than 50%, right? So it's technically a weak argument whether you're betting on black or red because of those 2 green slots that kind of essentially give the house some profit. In fact, though, I will say that a lot of people fall prey to this line of thinking. In other words, they think that because black has come up the last 5 spins, the odds that it's going to be red on the next one tend to go up. In fact, this way of thinking is so common, it's called the gambler's fallacy. And so you want to be aware of that if you have any temptation to think that the odds have gone up. The best way I have of explaining why the odds are always the same is to ask you to kind of put yourself in the mindset of the ball that goes around the wheel, right? And so the problem is with that is that the ball doesn't actually have a brain. So every time that ball goes around the wheel, it's saying to itself, if it could, oh my goodness, I've never done this before, right? Because it doesn't remember. And so the odds are exactly the same every time that ball goes around the wheel. All right. But I am not here just to save you money on gambling, right? If you fall prey to the gambler's fallacy, you probably want to stay away from casinos. I can also help you win money at a party, but as you see on my little note here at the bottom, this is really just for entertainment purposes only. So, obviously this is going to be a little bit different in terms of the online environment and through a video, but in many of my logic classes I have, say, 30 to 40 students in my logic classes, and I can say to them, well, there are at least 23 people here in class today, and so it is likely that 2 of us have the same birthday. And of course, this is in fact an inductive argument. Likely is right there, so we're talking about probabilities. And the question is, of course, is it strong or weak? Well, as it turns out, when you get 23 people together in a group, the odds are just over 50% that 2 of those people will share a birthday. That is not including the same year, right? But will share a birthday, whether it be March 23rd or December 5th or whatever it might be. The odds are that 2 of them will share the same birthday. You can see this book, which is in the Everett Community College Library, to see the math behind this. But I will tell you that what I do in my face-to-face classes with this is I actually, when my class has however many students it has, I go around and ask, well, how many people were born in January? And then people raise their hands, and I get to learn the names then as well, which is a good thing. And I go through the whole year if I have to, but very often, even in January, I will get 2 people that match. That is, one person will say January 5th, and another person will say, yeah, mine's January 5th as well. And we get a match, and I blow people's minds this way. We're not going to be able to do that here, but trust me, it is impressive, and you can see that book to see how this works out mathematically speaking. And I like to do this one as well. It sets up another couple examples here. Because there are 535 members of the U.S. Congress, it is likely that 2 of them were born on the exact same day. This is throwing in the year as well. Is that strong or weak? Well, it depends on that age range, right, of members of Congress. There are some members of Congress who are in their, 30s, I know, and of course there are members of Congress there that are in their 120s. I'm just making that up, but there's quite an age range. So it's not exactly clear to me, actually, if this is strong or weak, right? I also want to say that with regard to this first example here about the birthday, I realize that when you read that argument, it doesn't appear to be a strong argument, and I just want to say when it comes to the exam, I wouldn't offer either one of these kinds of arguments to you to determine if it's strong or weak, because I know it's certainly not clear in either case what the case is. That's not to say that the arguments are all going to be easy, but certainly I'm not going to try and trick you or give you anything that's particularly strange like these cases. Now, what if I said, on the other hand, because there are 535 members of the U.S. Congress, it is likely that 2 of them share the same birthday. So this is the game we were playing here at the top, and that's not including the year. If you think about this, right, well, it says it is likely, so we're talking about an inductive argument. And in fact, it is likely, it's very, very likely. If we're thinking of this as an inductive argument, we'd have to say it's strong. But in fact, we'd want to go back to the person offering this argument and say, you know what, it's more than just strong, right? It's guaranteed when you have 535 members and only 365 days to slot them into. It's guaranteed that 2 of them share the same birthday. And so you'd actually want to suggest to this person that they turn this into a deductive argument, right? In which case it would be a valid deductive argument.